Alright, let's look at theorem 1, angle side theorem. Right? So if you have, let's say, angle A and angle X are congruent, angle B and angle Y are congruent, and side BC is congruent to side YZ, right? Then we know that we need to establish that these two triangles are congruent. Right, so let's do that. Right, so I already I've written down the givens. Right, so what we're going to do is I'm going to just list all possible cases. Say triangle ABC is either not congruent to triangle XYZ, or they are congruent. So triangle ABC is congruent to triangle XYZ. Right, so this is just listing all possible cases. Right, so let's assume that since we want to say that they are congruent, so this is the one we want to keep. So let's pick on the other guy. Right, so let's assume that triangle ABC is not congruent to triangle XYZ. Right, so this is simply case 1. Right, so since we already have, if you look at angle here, angle side, and if you have the congruence between angle C and angle Z, then we would have a angle side angle, then they are congruent. So we have to prevent that. So we know that we know that angle C cannot be congruent to angle Z. Right, so this is by angle side angle, so by angle side angle. Alright, then we're going to make an extra assumption so that we don't have to separate it into two cases. Alright, so if they are not congruent, one is going to be larger than the other guy. So I'm going to just assume without loss of generality, because if it's the other way around, we can just do the same argument anyway. So measure of the angle C is strictly larger than measure of the angle Z. Right, so this is by without loss of generality. Right, if the inequality is the other way around, then we can do the same similar argument to symmetric argument to establish the same kind of contradiction here. All right, so let's assume that the C is larger than angle Z. All right, then we know that 8. Right, so if you have a larger angle, we can always chop it down. So I'm going to construct an angle here to match the angle Z. So I'm going to just cut it down a bit. Right, and I'm going to construct this point. I'm going to call it A prime. Right, so that the angle here matches the angle there. Alright, so we know that, let's see, we can construct, construct point A prime between A and B, such that angle A prime CB is congruent to angle Z. Right? So if that happens, then we can actually establish the congruent triangle, congruence between this triangle A prime BC and a triangle XYZ. Alright, so I'm going to go up here. So line number 9, we know that the triangle A prime BC is congruent to triangle XYZ. Right, this is by angle, side, and angle. Let's identify those angle, side, angle. So here angle would be angle B and the angle Y. So which is line number 2. Right, side is BC and YZ, so it's gonna be, it comes from line number 3, right? And last one is let's see here, line number 8. All right, then if that's the case, line number 10, we can say this: you have the angle here is going to be congruent to angle there. Alright, so you have angle B prime, B A prime C is congruent to angle X. Right, and so this is just corresponding parts of congruent figures. Right, and the number 11. Alright, but there's something weird happening here. You can see that here, this angle is exterior angle, and the angle A is the opposite interior angle. So we know that the measure of angle A is going to be strictly smaller than its corresponding exterior angle, which is measure of the angle B A prime C. Alright, so this is exterior angle inequality. Alright, then we can combine these, let's see, these two guys right here, number 12, combine line 10 and line 11. So alright, BA prime C is congruent to X, and A is smaller. So we know that the measure of the angle A is strictly smaller than measure of the angle X. So this is just combining line 10 and line 11. Alright, but this is a contradiction because it contradicts line number 1. So it's a contradicts line number 1. Right, so we got a contradiction, so therefore 13. Therefore the first case didn't work out, so there's only second case. So triangle ABC is congruent to triangle XYZ. Right, so this is by rule of elimination, and this was case 2. Alright, so that's the proof of angle-side theorem. Alright, that's it. I hope that this was clear.